We are using Matlab version 2016 and this is the circuit. This is the circuit diagram of differential protection of transformer. On this side we have a generator, after that comes our circuit breakers, and here is our transformer. After the transformer once again we have a circuit breaker. After the circuit breaker we have our load. So after the circuit breaker we need to measure the voltage as well as current, so that's why we have a VI measurement block here. And after the primary side we have one VI measurement block, and the secondary we have another VI measurement block. So let's do this basic block diagram on the Matlab 2016 version. So first thing we go to is Simulink. It will take a few seconds. Then we'll go to Simscape. In Simscape, we'll do electrical. Then we'll maximize this window, and then we'll select everything by pressing Ctrl A. Then we press delete. Then what do we do here is we start looking for these components in this library browser. So first thing that we do here is in this Simulink, then we go to Simscape. In that power systems, in that specialized technology. After that comes our fundamental blocks. Here we will have elemental sources like our three-phase source, that is our generator. So either I can right click and then say add block to model untitled, or else I can just drop with this three-phase source by holding a mouse. So after that, once again I will go to this, and then I will see elements. So in elements I will look after VI measurement. So here there is no VI measurement here. So here is the measurement block. So here is our VI measurement block. At the same time, now I want is three-phase circuit breaker. Three-phase circuit breaker is available in elements. So here is our three-phase breaker. After that, what I want is transformer. That is three-phase transformer, two windings. Zoom. Three-phase transformer, two windings. Okay. So once again, ma'am. Once again, it is a VI block. So to copy this, I'll select this and then press Ctrl and then start moving this to get a copy. Or else I can say, once I will click on this, then right click, then I will say copy. This I can do for any block. Pause now. Then once again I go to library browser. Then I want is a three-phase RC series RLC load. Here I get the three-phase series RLC load. So that comes after our three-phase circuit breaker. To rotate this, I press Ctrl and then say R, Ctrl R. Then I first will select this and then say Ctrl R. Now I got the basic elements of our basic diagram. So then I will take the three-phase fault. In this block itself we have a three-phase fault. So this will generate our fault in the Matlab for our system. Then I will connect each and every block. Pause now. Again I am starting the connecting these blocks to the RLC load. Then I will connect this fault to the secondary of our three-phase transformers. A to A, B to B, and C to C. But this three-phase should operate only when I give a signal. So for that purpose, I will double click this one. Then I will say, see, this fault will be line, line, line and ground. So it means triple LG fault will be there. I need to give an external signal to create a fault. So I will click here, external. Then I will say, OK. So this will create a external fault. Now I need a relay block. Before that, I will measure the voltage here and voltage here. At the same time, I will be measuring current here and here. Then I will be comparing the current values. Stop. I will go here once again to the library browser. Then I will go to Simulink. In Simulink, I will start looking for the options. Here is a Simulink in sync. I will get a display option. And even there is the option for scope. Scope plots a graph and displays the value. So I will go to what it is. I will take a scope and then connect the voltage VAB scope. Then once again I will copy this block and then connect this side we are measuring block to this scope. So this voltage thing got over now. Now I need to measure the current and then compare the values. So for that purpose, so I will use a demux. Then using the demux I will give the input to RMS, where RMS value will be calculated. Then this block will be given to a sum block. And this side, three-phase transformer, right? Once again we will calculate the RMS value. Then we multiply it by a gain, because it's a step-up transformer. Whatever current is there, it will get reduced by 3 times because voltage is getting increased by 3 times. So once again, to measure the current, I will give a gain of 3 and then compare this RMS current and this RMS current, means primary current and secondary current. If they both are equal, then our relay block will not operate. Only when the current is unequal, right? At that time our relay block has to operate, and our relay block has a absolute, then comes constant. So whenever these two values are equal, right, at that time a relationship operator will be greater. So whenever there is a greater value that is coming, only when this output will be 1, or its output will be 0. So that's how a SRP clock will be working. SRP clock will be acting as our comparator. So now I construct the relay block. So first thing I do here is I need a demux. So I'll go here. Then once again Simulink and common use blocks. So here is our demux block. Then I'll double click on this demux. I need 3 outputs because it's a 3-phase system. So now I got here. So now then I will connect the current here. So after that comes our RMS block. So what I do here is I will search for RMS here. I can search for any components in this search block. So I will see where is our RMS value. See, here is our RMS value. So I will use this block. So then I will connect this demux through RMS. So after the RMS, we need to give this to a comparator block. Before that, I need to connect the same demux and RMS block to this current output. So what I do is I select this demux and RMS. Then I will say copy. Then I will paste it here. Then I will connect this here. Okay. After that, I need to compare both these values. But as we know, the secondary current will be reduced by 3 times. So for that purpose, I need to add a gain here. So once again, I will search for gain here. So this is our gain. So I will give gain as 3. And then I will connect this block. Okay. Then we need to compare this and this. So for that purpose, I use something called as sum block here. So here is our sum block. I'll drop it here. So, but to compare, right, I need to do this plus and minus. That purpose I will give symbols plus and minus. Then I will rotate it using Ctrl R. It's given normally side. So positive side will be given by this RMS and negative by this RMS. Okay, then comes whatever value is the right, even if it's a negative, I should get only a positive value. For that purpose, I will add absolute. So once again, I will search here, or else the best thing I can do here is I will go to Simulink. Then here is our math operations. In math operation, I have absolute and all the symbols. Here I get absolute. No worries, man. And I have some block. All the things are here. So I will use absolute here.
Sir, ನೀವು internet use ಮಾಡ್ತೀರಾ?
ಇಲ್ಲ ರೀ ಮ್ಯಾಮ್. ಒಂದು 2 ನಿಮಿಷ ಮುಗೀತದೆ. So I'll then connect this block to absolute here. So after that, I need a relationship operator. I will use relational operator. Or else I can directly search here, relational operator. So here is our relational operator. Both these are the same things. Here is a common use block, and this is the where exactly that file is available. That shows here. Simulink logical bit operations, and then comes relational operator. So then I will drop it here. Then I will rotate it. So one input will be given by this absolute, and to compare that I will give a constant value. Once again I will search here constant. So here is our constant block. I will rotate it again. So constant here will be 2. This is our constant. So after that, here relational operator I want only greater sign. So I will double click on this, then go to relational operator. So here there are many equal to, almost equal to, less than, greater than. So I will choose greater than symbol, then say apply and OK, or even directly OK is fine. So I will then say OK. After that comes our flip flop. Compare the values. It's it acting as our relay block. So I will search SR. This is our SR flip flop, or directly can search flip flop, right? You will get a flip flop, list of flip flops. There I can choose SR flip flop. So I'll keep initial status as by default value itself. So then I will rotate it again. I will connect this relational operator to the R side, and to the S I will give a constant value again. Yes. And this value will be 0. To make it 0, once again I will double click on this one, then give 0 as now it's 0. And then I will see the Q output. Q output is very important. So I will take the Q output. As it's our flip flop gives a boolean values as output, I need to convert it into a double so that our circuit breaker can operate. So now I will go to once again data type conversion. I need a data type conversion to make the boolean value into a double type. So here is our data type conversion. So I will rotate it. So I will connect this block here, and to convert this I'm converting into a double. So once again I will double click on convert block, then I will go to this output data type. In that I will choose, there are so many options, double, single and all. So I will choose double. Okay. and after that I will give this signal. I need to give us this signal to a circuit breaker. For that, circuit breaker should have a external symbol, right? Here already 3 terminals are connected, but to make circuit breaker operate only to relays, I need to connect another external port. For that purpose, I will double click on the circuit breaker. Then I will, what I do here is I will give it as a switching time external, and I will initial status should be closed. Then I will say OK. Once again I will do the same with this circuit breaker. This initial status will be closed and this signal will be external. I will press OK. Then I will connect this to this circuit breaker. ಮತ್ತೆ ನೀವು ಮಾಡಿದ್ರೆ ಇದು ಅದೇ so then I will once again I will connect this to this okay. So our Q bar terminal is not terminated, so this will give a wrong error. So for that purpose I will need use something called as terminator, so that it will not give any error. Terminator. So here is our terminator. So I will rotate it and then connect it to the Q bar. Okay. So our 3-phase fault needs external signal. For that purpose, I will go to signal generator. Here are so many types of generators are there. I will specially use stair generator. And I will give this as an external signal to our 3-phase fault. And 3-phase generator, right? There are totally 4 time instances. So, but I will use only 2 as a time instant. So 0 and comma 1 will be fine. So here I will give everything as a 0. If any time interval is 1, right? That means it's giving a fault. So initial status will be 0. This is done. So then I will run it once to check any errors are there. I know there are certain errors here, but to check it, once I will run it for a while. I will click on run. This is our run symbol. Now it started running. It shows there are in 3-phase transformer 2 windings. There are so many errors. Stop it. The most important thing, it's when I run it, right, it's showing a, see, I am missing a power GUI. Power GUI is like a heart for our system. If without power GUI, our system cannot run. So it's like giving a signal to our system. It's supplying the power to our system. So here is our power GUI block. So here, once I give this block, right, then I will double click on this one. Then I will choose as a discrete value. Then I will say OK. Once again I will run it. Then it will say undetected demarks 4 similar not connected. This is not any issue for us, because out of these 3 terminals we are connecting only one. So another error is it's showing untitled SR flip-flop mux. It's expecting a boolean value here. But we are giving a double here, so it needs a boolean value here. What I do here is once again I'll go to untitled, and here is our double value. See, it's showing a double value here. For that purpose I will double click on this one again, and here is our signal attributes. Once again here inherit value, double, single, all values are there, but our flip-flops works on boolean values. So once again click on boolean, then I will say OK. Then I will run it again. It's now running. Okay. It's not showing any errors here now. So then I will click on scope. Double click on the scope. So it means our output is continuous means our power is coming in the system continuously. Now we'll create a fault. Once again we'll check even the scope 2 means after secondary side voltage will see. So our power is continuous. So then what I do here is I will create a 3-phase fault. So here is our 3-phase fault. So I'll create a 3-phase fault here. So I mean at 1 second, right, I will give a fault by making this amplitude, secondary amplitude as a 1. I will click OK, which means I have already created a fault. Now once again I will run this. Okay, boss. So now scope. See, after 1 second, our relay block has operated and tripped the power supply. Okay. So once again on scope 1. See, after 1 second, our relay block has operated and tripped the power supply. So I will do what I do here is instead of giving 1 second, right, I will take it as 5 seconds here to make it more visible. Which means I am at 5 seconds I am creating a fault at. Okay. Then once again I will run. So at the same time I click on scope. See, up to 5 seconds our system will be on, and after 5 seconds our system will be off. Okay. So in this entire block, right, I have not changed any values. Whatever default values are there in 3-phase source or whatever default values are there in 3-phase breaker except this initial status and this external signal. I have not changed anything. Even in 3-phase transformer the default values are there. In 3-phase measurement will not change anything. And 3-phase circuit breaker once again open to close status we are changing, and then external signal. And in 3-phase RLC load we have not changed anything here also. In 3-phase fault, right, I have given as an external signal. That's the only change that I have made. And in state generator the totally 4 amplitudes were there. 4 time instances I had taken only 2 and 2 amplitudes. And whatever time instance there I will creating a fault. And in the SR flip-flop, right, it will ask for initial status of Q. It can be 0 or it can be 1, but I kept it as a default value at 0. Okay. So here it's a constant. It will be constant, and that value will be inherited from the constant value. But only thing here is this constant value will be a Boolean value. It will be a Boolean value because our SR flip-flops are from the binary values, 0s and 1s. Okay. I have created a fault at 5 seconds. Okay, done.